So what I'm going to do and what I'm going to emphasize is that when there is something being multiplied in the denominator, you have to do that first before you go ahead and divide 680 by it. Okay, so this piece right here, I'm going to rewrite it underneath it, and I'm going to go 4 times 35.25. Right, I'm going to do that, and that's 141. Plus this, I can also do on my calculator, right? I'm going to go 3 times 75 times 1.12, and that is 252. Okay, so you've worked with this. You first figured out the denominator here. You cleaned this up quite a bit, and now if you know how to use your calculator well, you could actually do this without writing anything else down. You could go 680 divided by 141. Oops. Divided, right? As I said, you get this, and your calculator, don't clear it, just go plus 252. That's where rounding early can get you in trouble, right? If you do this, like, you shouldn't be rounding too soon, okay? Don't round early because that gets you in trouble. So it's 256.82 is your final answer. Final answers get rounded to 2 decimals, so that sticks. Something like this, whenever you see a fraction like that, it's kind of scary, okay? But it is really just top number times and then divide. I always go 3 times 250 divided by 14. It is essentially this. Okay, when you get something like that, turn it into this. Okay. Hi there.
Hello.
Grade 12 math?
Yeah.
Okay. Come on in. Yeah.
I'm here for Aaron.
Aaron?
Yeah.
He's not in yet. I'm losing it here. Oh, Ariane.
Yeah.
Okay, got it.
The numbers, only this number. We don't know about these cabins.
Yeah, that's why I put a sign on my door for the first couple of days, till students find it, right?
Yeah, there's no sign.
I know.
So first I went to that door, see the gender, and then I found out that okay, there's not this sign.
And to make matters worse, it's cabin 1, 2, 3, and then it's 5, 4. It's not even 4, 5, right? Like it. So I have students come by here all the time. Yeah, I'll give you a couple handouts in a bit. Okay. So that ends up being 53.57, right? So this is where it gets a little tricky. Okay, we're talking people, so you can't have decimal or partial people present, right? So I go dot 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 because it just continues, and then I do one last. This squiggly lines is approximately, and so you round to the nearest whole number. So 53.5, right? This 5 bumps that to a 4. 54 people. And if you don't want to lose marks, you better always have units if there are any units involved. Okay. So this is going to come back when we do probability. This type of calculation is going to come back. Okay. So get that written down. We already did some of the tax questions there. Okay. And next page here. So these questions that we're doing now involve before and after tax, right? If you go back, each scenario is asking you to find the price before and after taxes. Okay. So Jamira buys 4 tickets at 109.25 each. So 4 times 109.25, right? That's 437. That's before tax. That would be it. If the question says find out the cost before taxes, you're done there. And then what was the trick to add taxes to something? Let's see if people were, you joined me online, right? See if you were awake. What did I do here? Times 1.12, okay. So you go times 1.12, and that is 489.44. Okay. And if this is a review for you, good, right? If you're learning something new, then even better, right? After tax. Okay. So this is including tax, not including tax, and this is what should give it away, right? And we're going to use this a lot in this course. Taxes are everywhere, right? Next, we have Steve buys some parts for his car. As stated in the chart, calculate the total before and after tax. I want you to make sure you know how to do either one and watch out for the wording. So in a chart like this, it's probably best to go 4, right? Just multiply. If you're buying 4 light bulbs that are 750 each, let's just figure out what that is, right? 4 times 750, that would give you 30 bucks, right? 2 times 55, that'd be 110. 3 times 1250, that'd be 3750, right? And then 1 times 250 is just, it is what it is, right? 99. So you've calculated it for each category what it would be. And so we're going to add that up, right? So 40, 3750 plus 250, 99. And that's 428.49. That's before tax. Okay. We're going to add taxes to it. I told you, right? Whatever you see in the store and you're wondering what would it be with taxes, multiply it by 1.12. And dollar sign, okay? 479.908. Oops, you can't see the calculator there. It's 908, so the 8 bumps this to a 1. So it's 91 after tax. Okay? So the rounding is going to be important for you to master. You don't want to lose half marks here and there. What about E? E is saying determine the total taxes paid, just the taxes, right? Just the tax. In question D. So you want to take that 428. I did this on purpose so you see the difference, right? 428.49 multiplied not by 1.12 because this is the price, right? Or the total cost including taxes. You just want the taxes. So you're going to go times 0.12. If you just want to know how much was paid in taxes, you don't do the 1.12, you just do the 0.12, which is 51.42 cents, right? $51.42. So taxes only. Okay. We did some Pythagorean theorem yesterday, and I'm not picky how you do it as long as you remember how it is done. I'm just going to mention it one more time, right? There are 2 cases. where the hypotenuse is unknown, and the other case is when one of the legs is unknown. And so these are your formulas, right? These are the two formulas that we're going to use in this course. That's how I'm usually going to approach it. You probably know it as this squared plus this squared plus this squared, right? Like this squared, hypotenuse squared is equal to this squared plus this squared, but I get rid of the square here and introduce the square root right away because that's what you're going to have to do at the end anyways. So then it's there and you don't forget about it, okay? Determine the area of the triangles in A and B. I don't know if you remember, area of a triangle is base times height divided by 2, okay? So for A, it would be area. This is your base, 315, times the height happens to be one of the sides of the triangle, divided by 2. So you go 315, multiply 275. I usually go equals after I do this part, and then I divide by 2. So that's 4.33 squared inches. Okay. For the triangle here in B, that one is a little trickier. I don't know if you caught that. But this is what I'm going to say about height and the base and the height of a triangle meet at a 90. That's the crucial part here. So some of you might be like, yeah, this is my base, yeah. But neither one of these sides meet at a 90 here at this corner, right? Where do they meet at a 90? These two sides here meet at a 90 up here. So you're like, yeah, but that doesn't look like it's the base. Yeah, you would just have to turn that one around, and it would. The key is that it needs to be the base and the height, and they meet at a 90. If you wanted to use this as your base, you would have had to figure out what the height is going across here, which is too much work, right? So base there is 7.65, and it doesn't matter which one you call base and which one height really. But this one is given to us here, 13.8. We divide that by 2, so that's where you get the area. I made some changes to it, so that's why my answer key is not updated. So I'm doing this as we go. This is also squared inches, right? So you've got the area for this triangle and the area for this triangle. And like let's go back to this one. If I were to turn this one on you, right? If I were to turn this triangle, the area wouldn't change, right? Turning a triangle, so that's what I mean. Like even though it doesn't look like it's the base and the height, as long as they meet at a 90, right? Then that's what you go with. $10.46, Logan. Oh yeah, okay, Logan, you were answering the question earlier. Yeah, good, times 1.12. That's right. So reducing fractions, you know what? I have good news for you. That's not a big deal in this course, reducing fractions. So I'm not going to dwell on it, but I think that it would be nice for you to know how to do that before you leave high school. So basically, you try to find a number that goes into both of them. If you can't think big numbers, think small numbers, right? So for example, when they're both even, you can divide them by 2 for sure. So you cut them in half as many times as you can until you run out of options. So for example, they're both even. I can divide them both by 2. So half of 24 is 12. Half of 32 is 16. Keep going. Half and half, right? Half of 12 is 6. Half of 16 is 8. Half of, they're still even, right? So I keep halving them. So that'd be 3 and 4, right? You just keep dividing by 2. It just worked out that way, okay? Some of you are like, well, Mr. Dirksen, I saw that 6 went into both of them right away. 6 goes in there 4 times, right? And, oh, wait a minute. Never mind. 6 isn't it? But 8, right? 8 goes into both of them. 8 goes into 24 3 times. 8 goes into 32 4 times, and then you would have been done. Yes, that's fine. It doesn't matter how you get there as long as you make sure you divide both of them by the same number. Okay? Let's see here. 18 over 32. Half and half. Half of 18 is 9. Half of 32 is 16. You can't half anymore because, right, one is odd and one is even. So that's it. Over here, you should see that 25 goes into both of them. If you don't see 25, try 5. It will just take you longer. So if you divide this by 25, you get 3. If you divide this by 25, you get 5. Okay, because 25 goes into 100 4 times, so therefore 125, right, goes in there 5 times, so you're done there. And then this one here, what would work in this case? 7 goes into both of them, right? If you divide this by 7, you get 6. If you divide this by 7, you get 11. So it's 6 over 11, you're done. Again, I'm not going to dwell on it because you don't need to be able to simplify in order to, like, probability will have fractions, but you won't have to reduce. So that's good news for you, right? Let's keep going. We'll do some area questions here. And we might be able to make it through the whole thing. And I need you to just, if we don't make it through the whole thing, that's fine. Like the last 2 pages that deal with the triangles and stuff like that, if we don't get there, that'll be okay. Okay. 9, determine the area of the following. A rectangle, right? Area of a rectangle is length times width, right? So that should be pretty straightforward. Okay. So that would be 4 times 7.5 gets you 30. And make sure you add units to it. So we're in centimeters squared. That's very important, right? So when you will see me mark your tests or your quizzes or whatever, you might see from time to time an R that's circled. That's for rounding. U for units if the units are missing. And N for notation. So run. That's what I tell my students, run from these mistakes. So every time you see one of these on your, I will say, for example, let's say you forgot your units, right? I'll put a check mark next to 30 because that's correct, but there'll be a U right next to it. And so what does that mean? It's like, well, you got the answer right, but you will lose half a mark for forgetting your units, right? And stuff like that. Rounding, obviously, if you make a rounding mistake, then it'll be a check mark next to the answer, but there'll be an R indicating that you made a rounding mistake. Notation is not very frequent, but let's say you do a Pythagorean theorem and you say at the end, yeah, a squared is equal to 4 centimeters, right? It's like, wait a minute, if you took the square root, there shouldn't be a little power of 2 anymore on top of that, right? So that would be a notation error. So watch out for things like that. The one that I forgot to mention here is RE. This one is rounding early or too soon. Okay. So run from these mistakes. Try to not lose marks there because it does add up. Okay. So area of a circle, I don't know if you remember, area of a circle is pi times the radius squared. So if we're given the diameter of a circle, we know that the radius would be 25 divided by 2, which is 12.5. Okay, we need the radius in order to calculate the area. So area would be pi times 12.5 squared. And let me show you here. I don't want you to use 3.14 when it comes to pi, because you're actually rounding too soon. 3.14, some teachers may have done that at some point in your high school career, if you can call it that way. If you want to memorize on your study sheet, just put down 3.14159. Like that, I would accept if you want to use that for pi. If you go, I have a pi button on my calculator, but I need to press the shift button for it. So if you go shift and down here, you need to find where it is. That will have all of the, well, almost all, right, of the digits, enough to be accurate, right? And so find the pi button on your calculator if you have one, or write this down on your study sheet, right? Like 3.14159. And if not, just watch, is it Night at the Zoo or Night at the Museum or something like that, where the little Einsteins they keep on repeating the pi value. So watch that this weekend and you won't forget. So let's try this one here. You need to get comfortable with your calculator. So this is right now where you try this using your calculator. I can type this in exactly the way I see it. Pi times 12.5 squared. I can type that in and I get this. 490.87. It stays 87 because there's a 3 next to it, right? 43210 doesn't change anything. So 490.87. And we are in inches squared. Okay. If you don't have a two-line calculator, you may be better off starting with this. So you go 12.5 squared, and then you'll get an answer right away. As soon as you press that X2 button, it will give you an answer. And then just take that answer and multiply it by 3.14159 or whatever if you don't have the pi button. You still get the same answer. So you just need to get comfortable with your calculator, okay? A triangle with a base of 50 and a height of 25 yards. So that would just be 50 times 25 divided by 2. And that is 625, right? 625 squared yards. So whatever units you have, put a little 2 on top once you do areas. I'll let you do this one and this one. And what I would like, I'm just going to use that feature and get you to get used to that feature. I'm going to post a question right now on Google Classroom. It's going to ask you what is the answer to question D and E. Okay. So all I want you to do is to type in the answer for D and then go comma answer for E. Like just put them right next to each other and then just answer that question. It's not worth marks. It's just for me to see where you're at. Okay. And for you to see how that feature works. So I'll do that right now. So you go ahead and calculate that and then answer the question once you're done. Yeah, I'm reading it. Hold on one second. Well, I'm just going to pause the recording for. Key is to keep practicing, okay? Don't give up. You can do this, okay? Perseverance. Now determine the value of each expression. That's just a fancy word for these are not equations, okay? It's just there's no equal sign there, so just find out what that would be if r is worth 3.4. So it's important for you to know how to substitute, right? So the r here, I usually use a bracket for a substitution, and then you square it. It's asking you to square it, right? So I can go 4 times pi times 3.4 squared, and that is 145.27, right? The 6 bumps up to a 7 because the 7 is greater, 5 or greater. So it's 145.27. And there are no units. Pi r(s) plus pi r squared. So pi, and they're saying that r is worth 3 and s is 4.3. Okay, so wherever there's an r, we're going to put in a 3 there. And wherever there's an s, we're going to put in 4.3. Plus pi radius squared. So radius is 3. We're going to square that. If you have a calculator like mine, you can actually enter that in one shot. So you're going to go pi times 3 times 4.3 plus pi times 3 squared. If it's a one-liner and there's no division, you can do that in one shot. 68.80. That's what you're supposed to get there. And let's do B, and then I think I'm going to move on just so we have enough time. Okay. This always throws students off. I don't know if you remember from grade 11, if you have like 1/3, it's like, what do I do with this, right? This can be written, and this is for life, okay? Just go take that, because it's really 1 times that, which is just it, divided by 3. Whenever you see this, you have my permission to rewrite it like this. This is something we're more comfortable with, right? And then we plug in values. R is 5.2, square it, H is 8, and then we're going to divide all of that by 3. Okay, so try this using your calculator. Shift. I need to press shift. Some of you have a pi button. Right, so you square 5.2 and you multiply that by 8. So notice that I don't put brackets, but I put times every time there is a bracket. So you get that for the denominator, sorry, the numerator, and then you're going to go divide it by 3 to get the bottom, like to get the actual value. So it's 226.53. Right, 529, the 9 bumps the 2 to a 3. Oh, hold on, I'm reading that in a bit, okay? Let me just 5.3. I just saw somebody read here. Question E, why didn't you add the other sides? Okay, Logan, you're first. Okay, I'm going to answer that question. Good question. I'm going way back up here. Nothing wrong with that. Okay, keep asking. Because the formula for area is base times height divided by 2. Okay, and I told you that these two need to meet at a 90. And the 5 and this are the only two sides that meet at a 90. If the question had asked you for perimeter, we would have perimeter is the distance around. Then you would have had to add up all 3 sides, and you would have ignored the height going through it because it's not part of the side or the outline of that shape. Does that make sense, Logan? No, the base is not always the base is not always on the ground, so to speak. The base and the height make a 90, and so if there's a 90, you can turn that triangle every which way. The area will stay the same. Okay, but they need to meet at a 90. So B meets, this is like meets height, right? Like there's a 90 where they meet. Okay, there's a 90-degree angle there. Um, does that make sense, Logan? Okay. Next question, Ona. 7.25. Okay, so Ona, yours is, I think, taken care of. 7.25 it is, DNR. I got 65.97 on C. Oh, okay, this one here. 65.97, so I'm going to double check that. So I'm going pi times 3 times 4.3 plus pi times 3 squared. Still get 68.80. So Amari, I'm gonna see. I think I probably know what happened. Okay, so let me try that. Pi times 3 times 4.3. Like I'm just gonna do this first portion here. That's 40.5265, right? So I'm not rounding to 2 decimals because it's not my final answer yet. And then here I get pi times 3 squared, which is 9, right? Oops. And that's 28.2743. Actually keeps going, right, for both of them. So if I now take those numbers, I have a feeling that you went 0.53 there. You rounded early here, and then you went plus 28.27. Still get 68.8. So Amari, can you just check again? But sometimes when students round early here, or if you use 3.14 for pi or something like that, you might get a slightly different answer. But I think that is something else. But keep asking if you need more clarification. So I'm going to leave this one. So evaluate the following expressions again. You're going to recognize this in a bit, trust me. Vehicle finance, home finance has stuff like this. So basically, there's a bracket here, there's a bracket there, there's stuff happening in here. So let's go ahead and first figure out what that is. So we're going to go 235,000 minus 15,750, and that's 219,250, and that is in dollars. And then we have 687 per thousand. Okay. So when you have something like this, again, you multiply this by the numerator and then you divide it by the denominator. So these could have been flip-flopped, it doesn't matter, right? So times 6.87 divided by 1,000, and that is 15, and we're in dollars, right? 1506.25, right? The 4 bumps to a 5 because of that 7. Okay. What about here for B? B is different. These two numbers are not in brackets. Okay, so this number is glued to this fraction here because there's a multiplication happening, right? I don't know if you remember BEDMAS. right? First you worry about brackets, exponents. Division and multiplication, actually, it doesn't matter which one you do first. Addition and subtraction are next, but multiplication is before addition for sure. So you need to do this first. So you got to go 541 plus, let's figure out what this is. So it's 54,000 times 315 divided by 1,000. Okay. So that's 170.1, and that's also in dollars, right? And then you take that and add it to the previous 711 point. This would be wrong. This would be a rounding. You have to have, with money, you have to have two decimals no matter what. How are we doing, folks? Are we following? Yeah? Okay. Make corrections if you need to. Let me know online if, could you go over B again? Yes. So earlier we had a subtraction happening, but that was surrounded by brackets. And so we do whatever is inside the brackets, right, to get this number, and then it's multiply, divide. Here in B, there are no brackets around the first, around this addition, so you need to first deal with this. You need to deal with this first. So you got to go 54,000 times 315 divided by 1,000 to get this, the 170.10. And you bring this down with you. And it's at this point, once you've dealt with the multiplication and division, that you add the two up and you get 711.10. Does that make sense, Mark? Yeah. Yeah. Always ask, okay? Don't be, I do have an agenda, but at the same time, I want to address those questions, okay? So don't be shy. So one thing is that if I have my chat open, I don't hear anything when you say something. If you really want to catch my attention, I think raising your hand a couple of times, like just keep clicking it, then I think I hear that you're trying to say something, and I will skip 12. Right now, we won't have to worry about converting. So if you did that, good for you. Let's go to question 13 here. Okay. So we have a fraction here, and that is being multiplied by 100. Okay. So in this case, focus on the fraction first, and when there's anything happen up or down, technically that needs to be addressed. Any operation either in the numerator or denominator need to happen first. Okay, so there's stuff happening here, so let's add that up. Okay, so we're going to go 985 plus 215 plus 125. That is 1325 over, and that's all in dollars, over 2850, also in dollars, and then there's the times 100. So I'm going to stick with the way I've been doing things, right? You go this times that, and then you're going to divide by that. Even though because there's only numbers, single numbers, there's no operations anymore happening, you could go top divided by bottom, just like right? This is a fraction, you divide, and then you multiply by 100. So you can do that as well. So 1325 divided by 2850, right? Multiply it by 100. And I don't know if you remember from day one, when you divide a fraction, you get a decimal, but then when you multiply by 100, what is that going to end up being? Multiplying by 100 always turns into a percentage. So that's 46.49%. Let's clean this up here, B. What are we doing? How are we doing time-wise? Okay. So we have a lot of stuff happening here. Bed mass. Focus on what's inside the brackets if there's operation. There's no operation in here, so don't worry about that, but we're going to take care of these two here. So 0.45 times, right? You can do this probably in your head, right? 2150 plus 0.15. This is 650 minus, there's nothing there, so we just copy it down again. Okay. And now this is a clean one-liner where it's like multiplication plus multiplication minus multiplication. You could do that in one shot. So 0.45 times 2150 plus 0.15 times 650 minus 0.4 times 350, and that's 925. Okay, but right, that's what we're supposed to get. Not everybody's calculator is the same, so I often encourage, so we keep that 925 in your head, right? So that's 0.45 times 2150, so that's 968. It's okay to round because it's a dollar amount. Okay, 0.15 times 650, that's also 0.98 minus 0.4 times 350, that's 1.4, and that's also in dollars. And then we're going to figure out what that is. So 9.68 plus 0.98 minus 1.4. And you're like, what? This is supposed to be 925, Mr. Dirksen. If it is with dollar amounts, it's okay to round from one line, okay, from the work to the next. That's the only time a rounding early is not going to affect you. So if you get 925 or 926, I'm going to accept them both. Okay. Got 10 minutes left, so maybe I will just end with this, and that'll be it for today. Okay. So hang in there. Oh. Is there a reason why? Yes. So, good question. So the question is there a reason why there's a percent at the end? Okay. And the answer is whenever you have a fraction like this and it's multiplied by 100, it's always going to be percentage. It's going to be a percentage. And so mark my words in this course. There's going to be, at least three formulas that will end up multiplying by 100, and you want to add the percent symbol to it. Yes. Because this is essentially when you turn a fraction, right? If you multiply that by 100, you get a percent. And so that's universal. That's always true. Yes. I'm going to say my short answer is yes, Hayden. Yeah. Because technically, It's the little things, right? Remember that movie? I can't wait to see that one. Denzel Washington. These when there's a dollar sign up here and there's a dollar sign up here, I don't know if you've ever been taught that the units actually cancel out. So this ceases to be a dollar amount. Okay? Like if you find, let's consider this is a test score. This would be a pretty brutal test, right? If it's worth 2850, but you scored this much out of that much, you divide and multiply by 100 to get your score, right? Yeah. Mark, does that answer your question too about the dollars? All right. Okay, let's do this before we go. Um, let's tackle this one here. Solve for the unknown variable. So solve for the variable. What is a variable? It's your unknown, right? It's usually x, or it could be n, it could be y, it doesn't matter. So we're going to attempt to do that here, okay? You notice that, right, there's 0.56 plus 0.64 plus x times 100, and there's 65% on the other side, okay? So what you're going to have to do to get rid of the times 100, we're going to use inverse operations, okay? So the inverse of adding would be subtracting. The inverse of multiplication would be division. Okay, so they're opposite operations. Okay, so to get rid of the 100, that's the first thing. We're going to slowly remove stuff that is surrounding x. So we're going to divide this side by 100, and we're going to divide this side by 100. Okay, and that is going to leave us with 0.65. And on this side, we can actually cancel the 100 and the 100, because if you multiply and divide by the same number, you might as well just get rid of it because it won't affect anything, right? And then you have 0.56 plus 0.64 plus x is left. We can add these numbers up, right? So 0.56 plus 0.64, that's 1.2 plus x, okay? And what do we do now? I don't know if anybody remembers this, might have been a while. But this number, right, this is adding to x, so we're going to go minus 1.2 on this side, and we're going to go minus 1.2 on this side. That will get rid of this on this side, and it's 0.65 minus 1.2, and that's negative 0.55. So that is the answer to x there. Over here, I'm gonna when it's just a one-liner, I will tell you that when terms switch sides, flip the sign. Okay, that's a little note for what I'm about to do here. So you have 3n on this side, and you have an n on this side. The goal is to bring all variables to one side and all the constants or the numbers to the other side. So 3n is on the left-hand side of the equation, so it stays there. But this n is going to come over to this side, subtracting, because it's technically positive here, so it comes over subtracting. On the other side, you have your 10 there. It's already there. This 5 is going to come over adding. like this. Okay, so 3n minus n is 2n. 10 plus 15 is 25. Okay, now that you have the 2n, this is multiplying. We're going to do the opposite. Yeah. Oh, it's plus 5. Thank you. Thank you, Ona. Now we're right. Okay. Divide both sides by 2. N is equal to 7.5. And so that's how you do that. I think I only have those 2 examples. Should have had more. But it's just a warm up so you have seen it.